let's begin this lecture. So last class I was trying to introduce calculus to you. So calculus is a subject of rate of change. So calculus helps you to understand rate of change of certain quantity. So we are trying to understand rate of change of certain quantity. That is the whole subject of calculus, at least one part of it, which we call as differential calculus. So rate of change is not a simple definition. Many people, what they do, they write rate of change of certain quantity as change in that quantity divided by time, but that is wrong. So many write rate of change as rate of change of some quantity as equal to change in that quantity divided by time. This is how they write it, but this is not correct. This is what I told you in the last class. This is not correct. In fact, what you are writing as change in the quantity divided by time, this is called average rate of change. Average rate of change. It's called average rate of change. It's not called rate of change. Rather, it is called average rate of change. Okay, so rate of change, growth rate, speed with which certain quantity is changing, all these mean the same thing. So you sometimes interchangeably use these terms. So rate of change of, let us say, height, or growth rate of height, or you can say speed with which height is changing with respect to time. Speed of change of height with respect to time. Okay, all these mean the same thing. So I use these terms interchangeably. So rate of change, growth rate, speed with which that quantity is changing, all these mean the same thing. Okay, now similarly I can write average rate of change or average growth rate or average speed with which the quantity is changing, average speed with which that quantity changes. It could be height, it could be velocity, whatever, with which the quantity changes. These are all same. So the upper quantities which I am marking with a brown color, these all mean the same thing. The lower quantities which I am marking with a blue color, these all mean the same thing. Okay, so there is difference between rate of change and average rate of change. Please understand this. Okay, now going further, so in trying to understand rate of change, last class I introduced a very funny example. So I said a baby is born whose height is changing with time as h equal to t square. Very strange baby. Baby's height is changing with time in this manner. So if you know the time, of course our time starts from 0. Okay, so we are running the stopwatch and it starts from t equal to 0. So baby is born at t equal to 0. Just when baby was born, its height was 0. Then after 1 second, its height is 1 meter. After 2 seconds, its height is 2 square, that is 4 meters. So whatever is the time, square it, you get height. Whatever is the time, square it, you get height. This was the example I took. So baby's height changing with time. Baby's height changing with time. So in this relation which I have given, I was asking you what is the rate of change of height or growth rate of height. So our main task is to find rate of change of height, or you can say growth rate of height. Growth rate of height. This is our main task. So that's what is our main task, but we didn't directly start with this main task. Rather, we first started with average rate of change or average growth rate. So first we started with the average calculation. Later only we will understand what is exactly growth rate. First you calculate average growth rate, later you can calculate growth rate. First you calculate average rate of change, then you can calculate rate of change. This is our strategy. Last class I told you the difference between the two, average rate of change and rate of change. When you say average, when you use the word average rate of change, you calculate it in a time interval. You calculate it in a time interval. That means from one time to another time. Let us say 1 to 2 seconds or 1 to 4 seconds. So you are calculating in a time interval. So whenever you say average, it's calculated in a time interval. Whereas if you say rate of change, it is calculated at a particular time. This is calculated at a particular time, say 2 seconds or 3 seconds, etc. So when you are framing the question itself, you have to be very clear. Suppose if somebody says, what is average rate of change at 2 seconds? Meaningless, because he is saying average rate of change, but he is specifying only one particular time. Meaningless question. So average rate of change at 2 seconds, meaningless. Average rate of change from 1 to 2 seconds, very meaningful. Similarly, when you say rate of change from 1 to 2 seconds, meaningless. Rate of change at 2 seconds, very meaningful. So these are how you use these terms. So you must be very clear when you are articulating or when you are telling, when you are particularly saying something in physics, you have to be very, very careful, precise, correct. You cannot afford to make mistake. Even in English language, that's how physics is to be learned. Anyway, I also loosely speak of some terms and make mistakes. So I myself am not perfect, but anyway, I want you to be perfect because you are the students who will be writing IIT JEE. Having said that, now first, last time I was trying to calculate average rate of change. So we took this example h equal to t square, where h is the height of baby and t is the time at which you are looking at the height of the baby. Time at which you are looking at height of baby. So anyway, our time is starting from 0 and it is greater than or equal to 0. So our first task was to find average rate of change or average growth rate of this baby. Let us say from 0 to 1 second. First let's find that. Suppose I want to find average growth rate of baby from 0 to 1 seconds. When I say growth rate, it is measured in meter per second because height is calculated in meters and time is in seconds, and you are doing some kind of division, not exactly in all cases, but so first let us find average rate of change from 0 to 1 second. At t equal to 0, height is 0 square. Whatever is the time, substitute in that relation and you get height, so that is 0. At t equal to 1 second, height is 1 square, that is 1 meter. So from 0 to 1 second, height changed by 1 meter. So average growth rate is simply change in height by change in time. This is average growth rate. That's what you have been doing in 10th class or in the lower classes. So height increased from 0 to 1. So change in height is 1 minus 0. Change in time is also 1 minus 0, 1 second. So it is 1 meter per second. So average speed with which baby was growing, it's not the exact speed. On an average I calculated. The average speed with which the baby was growing from 0 to 1 second is 1 meter per second. Suppose if I calculate it from 0 to 2 seconds, suppose I want the same average growth rate from 0 to 2 seconds. So at t equal to 0, height is 0 of course. At t equal to 2, height is 2 square, that is 4 meters. So height changed by certain amount. So change in height 4 minus 0, by change in time 2 minus 0. So now the average growth rate is 2 meters per second. So you see average growth rate can be different for different time intervals. From 0 to 1 second, average growth rate was 1 meter per second. From 0 to 1 second. From 0 to 2 seconds, average growth rate is 2 meters per second. So you can calculate average growth rate like this. Just see what is the time interval. Okay, find the change in height divided by change in time. That is giving you average growth rate or average rate of change of height or average speed with which height is changing. All terms mean the same thing. Now, last class I introduced you what exactly is growth rate. I will now try to refine it and go much deeper into it. So now let's come to the task of calculating growth rate. So now same relation, h equal to t square, my t is greater than or equal to 0. Now I want to find growth rate, exactly growth rate now. And when I say growth rate, you have to specify the exact time at which you are trying to calculate it. Not a time interval, but exact time. So I want to find growth rate at t equal to 2 seconds. At t equal to 2 seconds. That's what I want to find. So what we will do, first let us do a small gimmick, a small magic. I want growth rate, but first I will try to find average growth rate. So let us see. I want average growth rate from 2 to 2.1 second. I'll calculate. Okay. What is my actual intention? It's to calculate growth rate at 2 seconds. But I can't directly find it out. So first I am trying to find average growth rate from 2 to 2.1 seconds. Okay. So the time at which I want to calculate growth rate is there. But I am slightly allowing that time to move a bit forward to 2.1 seconds. So I'll find growth rate from 2 to 2.1. Then I'll find growth rate from 2 to 2.01. Then I'll find growth rate from 2 to 2.001. And I continue like this, 2 to 2.0001. And I will get some pattern. I will check that pattern. What is the answer I am getting? Is it following some pattern or not? Like this I will go. And one day I will calculate average growth rate from 2 to 2 point, a million zeros followed by 1. And finally from this I will try to guess or try to argue or whatever the average growth rate from 2 to 2 seconds. See, first I changed the time from 2 to 2.1. That's quite a big change in time, 0.1 second. Then I am taking a new case where I am changing time from 2 to 2.01 second, where the change in time is 0.01 second. Then third case I am taking 2 to 2.001 second. So there the time change is 0.001 second. Like this I am taking a smaller and smaller time interval. One day I am trying to guess the average growth rate when time interval is 0 seconds. Time interval, change in time. That means time is not moving. Okay. So if time doesn't move, technically height also doesn't move. So change in height will be whatever value is at 2 seconds, that is 4, minus whatever value is at 2 seconds, 4, by change in time. So you are actually mathematically getting 0 by 0 directly if you do it. But I am trying to go in an indirect way. Calculus is all about this. Calculus is calculation of 0 by 0. To make it very simple for you, it's much more deeper than that. But calculus is, simply put, for our case, simply put, it's calculation of 0 by 0 by indirect method. That is calculus. Okay, it's not a perfect definition. So I am not really following very rigorous mathematics and giving you definitions. I am trying to make you understand things first. The rigor will come later. First you understand things, you can slowly build the rigor. You can make definitions more precise, more accurate, and that you will be doing in mathematics. So this is my strategy. This is what I am trying to do. So if I put it in English language, when you want growth rate at a particular time, you allow the time to change. Then next case you allow the time to change by smaller amount. Then third case you allow the time to change by even smaller amount. Like that you keep going. One day you reach a case where time doesn't change. Then you find average growth rate, that is growth rate. So if I put it in a simple way here, growth rate at t seconds is nothing but average growth rate from t to t plus some delta seconds, where ultimately delta goes to 0. Can you see this? ultimately delta is going to 0. Okay, I am going into a slightly higher level concept here. This will be useful for a later stage. So you see how I am defining growth rate. Suppose you want growth rate of baby at 2 seconds. First you find average growth rate from 2 to 2 plus delta seconds. What is delta here? It may be 0.1, 0.01, 0.001, whatever. Okay, but ultimately when you put delta 0, what will happen? You are finding average growth rate from 2 to 2 seconds only. Delta is 0. That means you are finding it at 2. At 2 means it is not average growth rate, but it is growth rate. So growth rate is nothing but average growth rate when time difference is going to 0. What is the time difference here? Final time minus initial time, that is delta, and that is going to 0. When that goes to 0, average growth rate becomes growth rate. This is the concept which I am using. So first let us see this in the case of the baby example. Okay, so no need to write any of this. I am going to upload this lecture in YouTube. You can make excellent notes later by slowly seeing this video and writing it. And everybody must see again the video lecture and make notes, because you cannot spend time seeing video lectures again and again. So you understand now, see once later and make notes, and later only revise notes, because notes is the most important thing in our course. Okay, those who just stick to notes and understand concepts and later do problems from assignments, any book, whatever you feel like, they will succeed. Those who leave notes and simply are going through some this material, that material, it will not work out. That's what my experience has told me anyway. Now let us first find, in this example, h equal to t square, growth rate at t equal to 2 seconds. So you can't directly calculate growth rate, so we should go via the root of average growth rate. So first I will take 2 to 2.1 seconds. How to find average growth rate? At t equal to 2, height is 2 square. At t equal to 2.1, height is 2.1 square. So average growth rate, so I'll write average growth rate. It is given by change in height, 2.1 square, final height minus 2 square, by change in time. So numerator you can simplify, a square minus b square. You can write a plus b into a minus b. That a minus b cancels with denominator. So ultimately you will be left with 4.1 meters per second, because numerator is measured in meters, denominator is in seconds. Now next case, so this is average growth rate from 2 to 2.1 I got. Next I will take 2 to 2.01 seconds. So at t equal to 2, height is 2 square. At t equal to 2.01, height is 2.01 square. So again change in height, so average growth rate now will be change in height, means final height 2.01 square minus initial height by change in time. Again use a plus b into a minus b, 4.01 meters per second. So this is average growth rate from 2 to 2.01 seconds. Along similar lines, now you can see some pattern. Average growth rate from 2 to 2.001 will be, if you calculate, 4.001. Similarly, average growth rate from 2 to 2.0001, you will get it as 4.0001. Okay, average growth rate from 2 to 2 million zeros followed by 1 in that time interval, very small time interval. So time is changing from 2 seconds to 2 million zeros followed by 1 second. Okay, this is very less than 1 second, very less. In that, average growth rate is coming out to be 4 million zeros followed by 1. So by this reasoning, I conclude that average growth rate from 2 to 2 is 4. If you directly calculate it, change in height by change in time, you get 0 by 0. But I went in an indirect route and I got 4 meters per second. So this is calculus. So calculus is trying to calculate 0 by 0 in an indirect route. So I got average growth rate from 2 to 2, but time is not changing. When time is not changing, you don't call it average growth rate, my dear, you call it growth rate. So growth rate at 2 seconds, growth rate at 2 seconds comes out to be 4 meters per second. That means at 2 seconds, the head of the baby was trying to shoot upwards with a speed of 4 meters per second. The head of the baby, feet are on the floor and head is moving upward and baby is growing. So head of the baby is shooting upward with 4 meters per second. This is how you calculate growth rate. So when you want growth rate at a particular time, allow time to change, but do it for smaller and smaller and smaller time intervals, and you will see what is the pattern. Is there a better way instead of going it like going in this manner? There is a better way, I'll come back to that. But we should go in a slow manner. We should not hurry to the shortcuts immediately. So first we should understand things and go in a slow manner. So this is what is happening. Let's do this before I go further. Let's do this for 2-3 more cases. Okay, 2-3 more cases to make ourselves very strong. So same h equal to t square. I want growth rate at 3 seconds. Now I want growth rate at t equal to 3 seconds. Remember, growth rate is calculated at a particular time. So first what we will do, we'll calculate average growth rate from 3 to 3.1 second. Okay, then we'll calculate average growth rate from 3 to 3.01 second. Then we'll calculate average growth rate from 3 to 3.001 second, like this, and we will see what is the pattern. From that we will be able to get what is growth rate at 3 seconds. So how are we going to do this? First you find height at 3 seconds. It is 3 square. Then that is initial height. I put I. Then final height at 3.1 seconds is 3.1 square. So now what you should do, change in height by change in time. So I am doing for this case. So change in height is 3.1 square minus 3 square. By change in time is 3.1 minus 3. Final time minus initial time. So if you simplify this, again you can use a plus b into a minus b, all your mathematical formulae. So you will get 6.1 meters per second. So from 3 to 3.01 you will get 6.01 meters per second. From 3 to 3.001 you will get 6.001 meters per second. So 3 to 3 million zeros followed by 1 you will get 6 million zeros followed by 1 meters per second. So at 3 it will be 6 meters per second. That will be the growth rate. Okay, at 3 it will be 6 meters per second. This is what is the final result. So growth rate at 3 seconds will be 6 meters per second. So now with this understanding, with this background, I want to take you into a better approach than what we are doing here. Taking time from 3 to 3.1, then 3 to 3.01, 3 to 3.001, like this doing and trying to see where it is going is a bit cumbersome, is a bit painful. So is there slightly better way? So going further we will refine this better and better and better. We will refine this. Okay, so now let's clear this slide. Suppose I want to find growth rate at t equal to 4 seconds. Now I will show you a better method. At t equal to 4 seconds. So what I will do, instead of taking 4 to 4.01, 4.1 second, 4 to 4.01 second, 4 to 4.001 second like this, I will cleverly choose 4 to 4 plus delta seconds. Sir, what is delta? My wish, if I want I will put it 0.1 second, 0.1. If I want I will put it 0.01. If I want I will put it 0.001, or I will put it 0 also in the end if required, if I require it. That's the clever thing which we are doing. Instead of taking always 4 to 4.1 second, 4 to 4.001 second, 4.0001 second, instead of doing all that, let's say 4 to 4 plus delta seconds. Delta you don't tell right now, you tell in the end. You will get all values by putting delta, no big deal. So let's find average growth rate. Let's find average growth rate from 4 to 4 plus delta. How are we going to find that? At t equal to 4, height will be 4 square. Time, if you square it, you are getting height. That's how the special child is born. Okay, he is born with a special status. He is growing like that. And at t equal to 4 plus delta, the height will be 4 plus delta whole square. So if I calculate change in height, final height minus initial height by final time minus initial time, this is giving you average growth rate. In the numerator there is a square minus b square format. You can use a plus b into a minus b. If you do a plus b, it will be 8 plus delta. A minus b cancels with denominator, so you are getting 8 plus delta. So see the beauty of this. Average growth rate from 4 to 4 plus delta is coming out to be 8 plus delta. One shot you got it. If you put delta 0.1, you will get 8.1. If you put delta 0.01, you will get 8.01. Now put delta 0, delta going to 0, then the value will go to 8. Okay, to whichever value it is going, that is the answer. Okay, you are putting delta you are taking smaller and smaller. First you took 0.1, you got average growth rate 8.1. Then you took delta 0.01, you got average growth rate 8.01. Then you took delta as 0.001, you got average growth rate as 8.001. So the closer delta is going to 0, delta value, what are delta values? Delta is 0.1, 0.01, 0.001 and so on. The final answer is 8.1, 8.01, 8.001 and so on. So as delta goes closer to 0, this value is going closer to 8. So whatever is the value to which it is going, that is my answer. Which value it is going? It is going to 8. So 8 is the answer. Question is, why can't you directly put delta equal to 0? Sir, why you are saying delta is going to 0? Why not delta is directly 0? There is a problem. If delta is directly 0, you see this expression. You see this. So I am showing it with a different color, a green color. You see from here to here. How did you get that step? By cancelling something in the numerator and denominator. What did you cancel? See, once again, let me slightly show you this calculation. Let me show you this calculation. So actually, if I simplify this, numerator will be a plus b, 8 plus delta, into a minus b will be delta, denominator will be delta. You are cancelling delta. That's how you got 8 plus delta. You have cancelled delta, keep in mind. Now how can you put delta 0? It's like cancelling 0. Suppose 8 into 0 equal to 7 into 0, you can cancel 0 and you get a wrong result. That's the problem. That's exactly the problem. 8 equal to 7. So whatever you have cancelled, you should make sure that it is not 0. So you have cancelled delta. So how can you put delta exactly 0? You can't put. But you can put delta 0.1, nothing wrong. You can cancel 0.1. You can put delta 0.01, you can put delta 0.001. So you are only checking where the value is going when delta goes to 0. Delta exactly 0, I don't care. I don't want that. I am not even concerned with that. Okay. You cannot put delta 0 because you cancelled it in the first place. But you can put delta 0.1, delta 0.01, delta 0.001. So the closer delta goes to 0, it is not 0, it is going closer to 0. The closer delta goes to 0, the closer the average growth rate goes to 8. So to whichever number it is going closer, that we call as growth rate. It is going closer to 8. So 8 is growth rate. 8 is growth rate. This is the indirect method of calculating 0 by 0. This is the indirect method of calculating 0 by 0. So how do we write this? So ultimately we are putting delta tending to 0. This arrow is read as tending to. Means delta is not 0, it is going closer and closer to 0. That arrow is read as tending to. So we write it like this. Limit delta tends to 0. Okay, delta is going to 0. What is the expression? Expression is this. Change in height by change in time. So 8 plus delta into delta by delta. So in the limit delta goes to 0, delta is not equal to 0. It is going closer to 0. We write that as limit, LT or LIM. People write like that. So in the limit, this is read like this. In the limit delta is going to 0. This whole value 8 plus delta into delta by delta goes to 8. Goes to 8. Okay. When you write limit, you are allowed to cancel delta because it is not exactly 0, it is only going to 0. Then where is this value going to 8? It's not exactly 8, it's going to 8. So whatever is that going to value, that we catch up, and that is our answer. That is growth rate. Why we are doing this? See, after all, calculus was brought into picture by Newton, the great physicist. So we know it better than mathematicians. So mathematicians say you cannot calculate 0 by 0. So we found an indirect method of finding 0 by 0. Okay. So we said delta goes to 0, it is not 0, hence we cancel it, and we see where the final answer is going to, that we call as our answer. This is the trick. Okay. Actually, it is something similar to saying 8 plus delta into delta by delta, cancel delta and put delta equal to 0. But we are not doing that, because immediately mathematician will say, hey, you cancelled delta and again you are putting it as 0. You can't cancel 0. So what we are saying, okay, I am not cancelling 0. It is going to 0, it's not 0. It is maybe 0.1, 0.001, 0.001. Then this answer is going to 8.1, 8.01, 8.001. So it is going closer and closer to 8. So my answer is 8. So that is it. So if I show it in a mathematical form, so let me write it once again. Let's do one more problem before I go into the mathematical form. Let's do one more problem. So because this is a very tough subject, it's not easy to understand. This requires some metal. So same h equal to t square. Suppose I want growth rate at t equal to 5 seconds. So what I do, take time from 5 to 5 plus delta, we will settle delta in the end. So at t equal to 5, height is 5 square. At t equal to 5 plus delta, height is 5 plus delta whole square. So find change in height, 5 plus delta whole square minus 5 square. By find change in time, 5 plus delta minus 5. Put delta tending to 0. How will you write it? Limit delta tends to 0. You write like that. So in the limit, delta is going closer to 0. In that limit, means delta is very, very close to 0. Not 0, but very close to 0. Okay, when you write this way, you can't tell the value of delta. Suppose somebody asks me, is delta 0.1, sir? No, it's smaller than that. Sir, is delta 0.001? No, it's smaller than that. Is delta 0.00001? No, it's smaller than that. Is delta million zeros followed by 1? No, it's smaller than that. Sir, please tell me value of delta. Sorry, I can't tell. It's close to 0. That's what I tell. Anyway, now if you simplify this, limit delta tends to 0. Simplify numerator, a plus b, which is 10 plus delta, into a minus b, which is delta, by delta. When you are doing limits, you are allowed to cancel delta, because delta is only going to 0, it's not 0. So ultimately where this value will go to? 10. So the limiting value is 10. Limiting value, we say, limiting value means the value to which it is going is 10. That 10 is our answer. When delta goes to 0, 10 plus delta goes to 10, correct? Suppose delta is 0.1, the value will be 10.1. Delta is 0.01, value will be 10.01. So when delta goes to 0, the value goes to 10. We are only saying goes to. Is delta exactly 0? No. No. We are escaping from mathematicians. Delta is only going to 0, value goes to 10. 10 is what I want, 10 is my answer. So growth rate is 10. So this is what we are doing. Now, if I do it in a more general way, instead of finding, so you see how I am slowly going into more and more complex concepts. This concept is called limit, by the way. Later in mathematics, you will learn about limits. Limits. Okay? Limiting value. Limiting value means it's not exact value. It's only the value to which it is going closer. Suppose you are standing here and there is a wall. The distance between you and wall is 10 meters. Okay? Suppose I put a restriction. Always you should walk half the distance between you and wall. Always you should walk half the distance between you and wall. So first you jump to 5 meters, because half of 10 is 5. So now you are here. This is 5. Then again you jump to half, 2.5. So you are at distance of 2.5. Then again you jump to half, 1.25. Like this you are always walking half of the remaining distance. Will you ever reach wall? Technically no. Because always there is some distance left. You are only walking half of remaining distance. But one day you will tend to wall. You will tend to wall. You are tending to wall. Okay? So you are very close to wall. That is the meaning of tending to. So the limiting value is wall. Limiting value. You are not reached there. but in the limit you are tending to the wall. So the limiting value is the wall. That's the meaning of this concept. Anyway, now take the same h equal to t square. Instead of finding growth rate at 2 seconds, at 3 seconds, at 4 seconds, at 5 seconds, I just I want growth rate at t. I want growth rate at t seconds, at general time t. That's the beauty of calculus. In fact, calculus is language of variables. Calculus is a subject of variables. You deal with variables in calculus. Okay? You don't deal much with constants in calculus. You deal with variables. Here time is the variable. Okay? So, how to find growth rate at t seconds? First we will find average growth rate. We'll first find average growth rate from t to t plus delta seconds. Okay, we'll find average growth rate from t to t plus delta and put limit delta tends to 0. We will take the limiting value of delta to be 0. Okay, limiting value means it is very close to 0. It's not yet 0 but very close. That is the meaning of limiting value. So this is what we will do. So at time t seconds, at t equal to t, height is t square. At t equal to t plus delta, at time t plus delta, so I better write at time t. At time t, and similarly at time t plus delta, new height is t plus delta whole square. So average growth rate is change in height, final height minus initial height, by change in time, final time minus initial time. This is average growth rate. To make it growth rate, what you should do? Limit delta tends to 0. This you have to calculate. So let's calculate this. So this will be limit delta tends to 0. Numerator you simplify. It's a square minus b square form. A plus b, that will be 2t plus delta, into a minus b, that will be delta, by delta denominator. Denominator is delta. Can you see that? Denominator is delta. Delta you can cancel. Why? Because it's only tending to 0. It's not exactly 0. So ultimately this value will tend to 2t. The tending value you catch hold of, that is called growth rate. So when the height was t square, growth rate was 2t. Growth rate was 2t. Okay. So let me show you some interesting things. Height is t square. Growth rate, we write it like this. Growth rate is 2t. So if so let's calculate this at different times. At t equal to 1 second, height is 1 square. Growth rate is 2 into 1. So height is 1 meter. Growth rate is 2 meter per second. At that moment it was growing with the rate of 2 meters per second, baby. At t equal to 2 seconds, height is 2 square, 4 meters. But growth rate, how fast is the head trying to rise up? What is the speed with which head is rising? That will be 2 into 2, 4 meters per second. Similarly, at t equal to 3 seconds, height is 9, but growth rate is 2t, 2 into 3, so 6 meters per second. So at 3 seconds, height of the baby is 9, but head was moving with a speed of 6 meters per second at that moment. Head was shooting upward with a speed of 6 meters per second. So now anytime you can calculate the growth rate. Okay, now if you carefully look at what we have done till here, okay, so I want to erase all the slides and now go further into more deeper concepts. So if you see what we have done till here, let me show you that mathematically what we have done. See, if you find change in height, I wrote delta h. Delta h means change in height. Okay, whenever you write delta, it is to be read as change. It is to be read as change. So I am finding change in height, delta h, and I am finding change in time, delta t is change in time. So I am doing delta h by delta t, which is change in height by change in time, change in height by change in time. This is giving me average growth rate. This is giving me average growth rate. Please understand this. But Later, if you want growth rate, what you are doing? You are reducing the time interval to 0. The denominator which is time interval, it is going to 0. Okay, for example, you want growth rate at 3 seconds. You took first 3 to 3 plus delta. What will be the denominator? Delta, which is time interval, which is going to 0. So if you put time interval going to 0, it will become growth rate. So delta H by delta T gives you average growth rate, but in the limit that denominator delta T goes to 0, this whole thing is giving you growth rate. This is giving you growth rate. So understand, without limit, just this quantity, this is average growth rate. This is average growth rate. With limit, this is growth rate. Can you see this? Why denominator is going to 0? Let's take the same baby example, H equal to T square. Okay, see carefully. Suppose you want growth rate at T equal to 3 seconds. At T equal to 3, I want growth rate. So first what you will do? Take average growth rate from 3 to 3 plus delta. So what is the time interval here? Time difference. Time interval is delta seconds. Time interval is delta seconds. Time difference. Okay, please keep that in mind, time difference. So at 3 seconds, height is 3 square. At T plus 3 plus delta seconds, height is 3 plus delta square. So change in height, that is 3 plus delta whole square minus 3 square, by change in time, 3 plus delta minus 3. If you simplify this, numerator is average growth rate. This is average growth rate from 3 to 3 plus delta seconds. Okay, numerator is 6 plus delta into delta by delta. Don't cancel delta, because right now don't cancel it. Then to make growth rate, what you will do? You will put the time difference delta tending to 0. So limit delta tends to 0, 6 plus delta into delta by delta. What is this? If you carefully see, what is delta? Time difference, that is denominator. That's why I wrote the denominator time difference is going to 0. When that goes to 0, you get growth rate at that time, particular time. Time difference goes to 0 means it is at a particular time. It is happening at a particular time. Then you are getting growth rate. So mathematically, what I can write now is this. Please, I hope you understood this. You got this idea what I am trying to say. So when you calculate delta H by delta T, change in height by change in time, this is only average growth rate. But when you calculate delta H by delta T with that delta T tending to 0, this is called growth rate, or I can say rate of change of height of baby. Okay, or some people say even more precisely, rate of change of height with respect to time. Rate of change of height with respect to time. That is what is the meaning of this. Without that limit, it is only average. With that limit, with that time difference going to 0, it becomes growth rate. So if you refer to any textbooks, any good standard textbook, Resnick and Halliday, University Physics or H.C. Verma, any good book, they would define it this way. Okay, but they would directly go to this. They would not explain the way I have explained to you in very great detail. They would directly write this. So to bring you to this point was all my previous discussion in a systematic way. Okay, so this is rate of change of height, or you can say rate of change of height with respect to time. So we will have a small 10-minute break. We'll again meet at 4 o'clock because it's a 2-hour lecture. I don't want you to just feel strained over my lecture. So we'll have 10 minutes break, and we will continue from here and go much more deeper into calculus now. We will go much more deeper into calculus. I will talk about dependent variable, independent variable, how things are defined in mathematics from mathematics perspective, and then I will take you into derivatives, and I will do some examples, talk about some rules, and later maybe send you an assignment also so that you can practice. Okay, so we'll meet again at 4 o'clock.